Alright, I'm going to be working out several homework problems from your homework, which was on page 463. You were assigned problems 4, 6, 12, 14, 16, 18, 20, 22, 28, and 30. So I'll work out about a third of them. I'll start with problem number 6. It's the first one I will do. And all evens from the ones that they're all evens. So number 6. Number 6, you have 9 times 9 to the 5th power. So you're multiplying a pair of exponential forms, and in both cases the base is the same. It's a 9. The exponent for the first one is a 1. It's hidden. The exponent for the second one is a 5. So 1 plus 5 is a 6. So 9 to the 6th power is the answer. Next, I'm going to work out problem number 18. Number 18, you have this particular problem here. Parenthesis inside the parenthesis, another parenthesis with negative 14 times 22 all to the 5th power. Now, if you remember, in this case, it looks a little strange, but this is a power to the power problem. The negative 14 is to the first power. The 22 is also to the first power. So essentially what you're going to be doing is multiplying the powers here, because again, this one has a power to the first and this was to the first power. So you're going to be multiplying 5 times 1. The base doesn't change. You're going to get negative 14 to the 5th power times 22 to the 5th power, because again, this is power to the power type of a problem, and in these problems the base doesn't change and you multiply the exponents. And while they didn't give you the exponents for negative 14 and 22, you assume that there's a 1. There's the hidden 1. So 1 times 5 is 5. 1 times 5 is 5. So that's that particular problem. Let's see here. And number 16 is similar to that one. This is a more difficult case. Next, I will do problem number 30. For number 30, you have parenthesis 5 times p times q all to the 3rd power. Yet again, this is a problem that's power to the power, so a power of a power. And in this case, the base doesn't change and you multiply the exponents. All of these have a hidden exponent of 1. So 1 times 3 is going to be 3 in each case. So you're going to get 5 to the 3rd power, p to the 3rd power, q to the 3rd power. They're still being multiplied to each other, of course. And to simplify this, well, I didn't simplify it over here just because the bases and the exponents were quite large. You can definitely do that with the 5. So you can write down 125, because that's what 5 to the 3rd power is. 5 times 5 times 5. 5 times 5 is 25. And then 25 times 5 is 125. P to the 3rd, Q to the 3rd. So that's 30. And then I will do 38. For 38, you have, I guess this is a bit of a more complicated problem. And always, I'm hoping that you're actually trying these on your own before you watch the videos to get the most benefit out of this homework assignment. So I guess it's a bit of a compound problem with multiple steps and multiple things happening. First, I would take care of Sorry for the shaking. Fix my table. So first of all, what I would do is I would deal with this, and I'll do that below here. Again, this is a power to the power problem. The negative 10 is a power of 1, and the n is a power of 1. They're hidden. So one time the base remains the same. 1 times 2, that's 2, and 1 times 2, that's 2. So down here we have that. Over here, again, a power to the power problem. The negative 4 has, again, a hidden power of 1, so 1 times 3, that's 3. The base doesn't change. Here, the n has a power of 3 already, so 3 times 3, that's 9. Alrighty. Good. Now we can do a little bit of simplification right over here. We can easily go negative 10 times negative 10, because negative 10 to the second power, that's what it means. It's going to be a positive 100 because negative times negative are positive, so negative 10 times negative 10 is a positive 100 n to the second power times, and over here we have 4 to the third, negative 4 to the third power. Again, we can simplify that. We can simplify that by going 4 times 4 times 4, or negative 4 times negative 4 times negative 4. So negative 4 times negative 4 is a positive 16. Positive 16 times negative 4 is a negative 64. And then n to the 9th. Now with the constant values, these you can derive through just simple mathematics. 100 times a negative 64, well, that's simple. You just add 2 zeros at the end here, so negative 6,400. For the variables, they have the same base of n. And we know what we do when you have a variable with the same base and different powers and they're being multiplied. You add the powers or the exponents. So it's going to be n because that doesn't change. 2 plus 9 is 11. So this is this problem fully worked out. I know it looks a little bit complicated. That's because it's actually a compound problem. Let me do one more. One of the earlier problems, just to make sure that we have no problems. I'll do one of the ones that you were assigned. I'll do number 16 as well down here. So number 16, we have 17 times 16 all to the power of 4. So this is again one of these power to the power problems. You have the hidden ones for each. 1 times 4, that's 4, so you'll have 17 to the 4th power times 16 to the 4th power. Now of course you can simplify this, but these are going to be just very, very large numbers. And the important thing to remember here, you can't add the two exponents because the bases are different. And no, you can't really, the only way you would solve this problem is if you were to take 17 to the 4th power, then take 16 to the 4th power, and then get the product of the two, which would give you a very, very large number. In this case, you can leave this one as is. This is why I wanted to do this particular problem as well, even though it's kind of out of order. So that was the homework for today. I will go over the other problems, or even these problems if you want me to, in class when we get back, depending on the day, because we have the CASI schedule. So on Thursday, I'm guessing for most of you, yeah, Thursday is when we'll go over this homework. All right, thank you for watching.